Okay, just another example here. If your polynomial in x equals x cubed minus 5x squared minus 2x plus 24, show that p of 3 equals 0. And this is what we were doing yesterday, and hence factorize your polynomial. Now, see, sometimes you're given a hint of what one of the factors are, sometimes you're not, okay? So, in this case, you're lucky because they're saying show that p of 3 is 0, and if we can show that p of 3 is 0, it means that what is a factor? X minus 3 is a factor, and that there's no remainder. See, because if p of 3 is 0, you have no remainder. So it means that x minus 3 divides exactly into that polynomial. And if something divides exactly into something else, it's a factor of that. So let's do p of 3. We get 3 cubed minus 5 times 3 squared minus 2 times 3 plus 24 is 27 minus 45 minus 6 plus 24. Minus 51 plus 51, that works. So I just look at the negatives and the positives. Minus 51 and plus 51 with the plus numbers, that equals 0. So we can say, therefore, x minus 3 is a factor. Now we can factorize it by how? Dividing. So look, some people don't divide, they try other things. They try and look for other factors, but we're going to do that next, all right? So now we divide it into x cubed minus 5x squared minus 2x plus 24. Okay, so you want to do, if you want, you can do your division, okay? I am going to show you another way of doing this, but okay. So what have we got? X squared. So we've got x cubed minus 3x squared. And we've got negative 5 minus plus 3x is negative 2x squared minus 2x. We've got minus 2x minus 2x squared plus 6x. Negative 2x minus 6x is negative 8x plus 24. Remember, you've got to get no remainder. So negative 8x plus 24, which is 0. Great. And so therefore, your polynomial is, looking at the division, this polynomial in here is equals x minus 3 times x squared minus 2x minus 8. And so therefore you could factorize. So it's x minus 3, x minus 4, x plus 2 with factorizing that last expression. Sorry, there is a bit of a time delay on the video today. It's playing up. Now, you know, some people work out the other factor using another method, and I'm going to show you that method now. The other way you could do this is, once you know that x minus 3 is a factor, this is the other way we can do it, by inspection. So we can say x cubed minus 5x squared minus 2x plus 24. You know how we were dividing x minus 3 into it? One of the factors is x minus 3, but we've got two other linear factors, but I don't know what the two other linear factors are. What do I have to multiply x by to get a cubic? X squared? So I'm going to put that my leftover bit here is ax squared plus bx plus c. Now, this is how people can do this by inspection if they wanted. Now, if you're going to get, you tell me what a's got to be. Where does your x cubed term come from? From multiplying x by the x squared term. But just by inspection, what does a equal? A has to equal 1. Where does your constant term only come from? Look, if I multiply the x by the first thing, the second thing, this last thing, everything's got x's. If I multiply the negative 3 by each of those terms in the second bracket, the only place my constant term comes from is where? Negative 3 times that constant. So I know that negative 3 times c is 24. Do you get this, what I'm doing? Look, you know how we were looking at the degree of the polynomial before? X times x squared gives you the x cubed. The a has to be 1 because this is monic. And the negative 3 times the constant term, if I multiplied everything out, I'd only have one constant term. It comes from multiplying this constant by that one in the whole of the expansion. I don't want to multiply 6 things. All right? So I know that negative 3 times that c gives me 24. That's where it's come from. What does c equal? Negative 8. So this is what I know so far, that x minus 3, x squared plus bx minus 8. That's the factorization. So we're just missing out. Look, some people do it this way. They do it by inspection. You don't have to, all right? You can just do the long division, all right? So we're just missing out on what b is. Now, we've got to say, now, look, this does get a little bit trickier, because you've got to work out where your x squared terms come from. If I was multiplying, where would my x squared terms come from? Wouldn't x times that one gives me an x cubed term, x times bx, there's one, bx squared, that's just an x term, and minus 3 times the x squared gives me an x squared term. If I was to multiply this out, where would the x squared terms come from? Not from x times x squared, but from x times bx. Do you get that? Not from x times the constant. Negative 3 times x squared gives me an x squared term. Negative 3 times bx doesn't give me an x squared term. Do you get that? So that's where they come from. Doesn't that equal negative 5x squared if I see what my x squared term is? Can you see what b is then? What's b? How do I get that equal to that? Isn't bx squared equal to negative 5x squared plus 3x squared? In other words, bx squared is negative 2x squared. Can you see what b is? What's b equal to? Negative 2. Look, you can just do the division. But what I'm doing here, when we do binomial theorem in year 12, you do a lot of this. A lot of it. Okay, so I just want to introduce you to the idea now. So therefore, I know that b is negative 2. I could have also equated the other way I could have worked out what the b is just work out my x terms. Where do my x terms come from? Not from x times x squared, not from x times bx, but from x times negative 8. So I've got negative 8x, negative 3 times x squared, negative 3 times bx is my other x term. They're my only x terms. That would equal negative 2x. So therefore, negative 3bx is negative 2x plus 8x, which is 6x. And here as well, I can see that b would, by comparing, so negative 3b is 6. So therefore, b again is negative 2. I could do it that way. Process. You can use this. You can just do the division. But there will be some harder questions later where we're just looking for a constant, and we'll be able to use something similar to this. Okay? Now, you could be given a question such as the following with no guidance. Factorize x cubed minus 4x squared minus 3x plus 18. Now, you have no idea. They didn't say to you, oh, we know that p of 1 is 0, or p of 2 is 0, or p of 3 is 0. You have no idea what the factors are. Now, where did this, just think what this is. Wouldn't this be, you're going to end up with x minus something, x minus something, x minus something. Do you agree? Right? What we're going to have to do is this plus 18 comes from multiplying 3 numbers. All right? But what we do, we just need to know what the factors of 18 are to work out what one of these numbers might be. We don't need them all, we just need one of them. So you tell me what the factors of 18 are. So factors of 18 are, well, we can have plus or minuses as well. We've got plus or minus 1, plus or minus 2, right? So I'm just going to keep this on the side. Factors of 18. We've got plus or minus 1, plus or minus 2, plus or minus 3. 4 doesn't go into 18. What is plus or minus 6, plus or minus 9? Now, you don't have to try them all. We're just going to try one. So, I don't think p of 1 is going to work. I'm just looking at this. Look, p of 1. So, we're going to try 1. So you've got to pick one of these that you think when I substitute it in is going to give me an answer of 0. All right? P of 1 I know is not going to work. 1 cubed minus 4 times 1 squared minus 3 times 1 plus 18. Look, it's 1 minus 4 minus 3 plus 18. Don't even work it out. It doesn't equal 0. I can tell already. It's 19 minus 7. It's 12. You don't have to put what it equals. Just put doesn't equal 0. We could try negative 1. I don't think that'll work as well. I don't think it's going to work. Let's try P of 2. Pretty sure P of negative 1 won't work as well. Just looking at it, I can tell. All right? P of 2, let's go. 2 cubed minus 4 times 2 squared minus 3 times 2 plus 18. That's 8 minus, what? 4 times 4, 16. Minus 6 plus 18. You know what I do? I've got minus 22 plus 26. I just look at the two minuses and the two pluses. I don't think that equals 0 as well, unless I've made a mistake. That doesn't. It's negative 22 plus 26. That doesn't equal 0. It's 4, isn't it? I think it's 4. Doesn't equal 0. You could try P of negative 2, or you could try P of 3. Let's try P of negative 2. All right, let's just see. Look, we know what P of 2 is. The values are going to be the same except plus minus. What's the first one? Positive or negative 8? Negative 8. It'll be minus 16. I think the next one's plus 6, plus 18. Oh, this one looks good. This is looking good. See, you know what I did? I just looked at these answers, but that would be a negative. This is the same sign. That would be a positive. Look, minus 8 minus 16 plus 6 plus 18. I think it equals 0, doesn't it? Yes? So if P of negative 2 is 0, therefore, what's the factor? X plus 2 or X minus 2? X minus negative 2, which is X plus 2 is a factor. And we say, great, I can start my division now. Once you've got a factor, you can divide. Now, I don't know what you want to do. I can already tell you what the other factor is already, maybe. If I put it in that, do you want to do, it's a monic. Do you want to try what I just did or not really? Or do you want to divide? All right. So let's divide. X plus 2 into x cubed minus 4x squared minus 3x plus 18. Off you go. No remainder, which is great. So therefore, x cubed minus 4x squared minus 3x plus 18 is equal to x plus 2 times x minus 6x plus 9. Isn't that a perfect square? X minus 3 squared, which means you should know how to draw that.
X squared.
X squared. Thank you. X squared minus 6x plus 9, which is x plus 2, x minus 3 squared. So you should know how to draw that. Remember? Positive, which shape? Like that. Bounces off at?
3.
Cuts through at?
2.
Negative 2. So if I did want to sketch it, it's not telling you to sketch, but it cuts, it's that shape because it's a positive cubic. It cuts through it 2, it bounces off at negative 3 because that's your single root at negative 2. And your double root now at and your double root's at 3. So you know when I decided to go up here and try negative 2, if I would have tried 3, it would have worked. Do you get it? If I would have tried 3, it would have worked. So, you know, some of you might be dividing by x plus 2, others of you might be dividing by x minus 3, depending on whether you tried negative 2 or not. All right? But you'll all get the same answer, okay? So, all right, that's, so therefore we've factorized it. If I want to do it the other way, it'd be x squared cubed minus 4x squared minus 3x plus 18 equals x plus 2. Now that's a single x, so I have to have a quadratic here. Does that make sense? Ax squared plus bx plus c. Now the good thing about this method, I can already tell what A is because it's monic, and I can already tell what C is. So you tell me what A is. How do you get your x cubed term Your x cubed term comes from multiplying the x cubed term, so this is the alternative method, comes from multiplying x and ax squared. So a has to be 1. Right? The 18 comes from multiplying the plus 2 with the plus c. So 2 times c is 18. Do you see? Therefore, c is 9. Do you see that? So I could rewrite this out and say that's x plus 2, x squared plus bx plus 9. Now, I can either now decide to match up the x squared terms or the x terms. I should get the same answer for both. So I'm going to highlight where the x squared terms could come from, or show you. 2 times x squared will give me an x squared, and x times bx will give me an x term. Give me an x squared term as well. Look, that gives me an x cubed, that gives an x squared, that gives an x, that gives an x squared, that gives an x term, that gives a constant term. So my x squared terms are coming from, I've got 2x squared plus bx squared is negative 4x squared. You can see what it is now. 2, b is negative 6. So bx squared is negative 4x squared minus 2x squared, which is negative 6x squared. You can just see by inspection that b is negative 6. So b is negative 6. So you can come back up to the factorization and say that your polynomial in x is x minus 2, here we were, x squared minus 6x plus 9, which is x minus 2, x minus 3 squared. Same. All right, you would only do this for monics or maybe a prime number in front of your x cubed term. Because if it was like a 2 in front of the x cubed, you know you've just got 2 for the a. Do you get it? All right. It is the same. Oh, I meant to put a plus. Sorry, it's just a transcription error. X plus 2. Yeah. So that's the other way of doing it.